catalyst speeds up a reaction by lowering the activation energy. And there are many types of catalysts, and first we're going to look at enzymes, which are biological catalysts. Let's say that this represents our enzyme, and the place where the reaction occurs is called the active site of the enzyme. So right in here, let's say this is our active site. And then the substance that reacts at the active site is called the substrate. So this little picture here with two triangles together, that's the substrate for our reaction. In the next step, the substrate binds to the enzyme at the active site. And when the substrate binds, the substrate can produce changes in the shape of the active site that allow for better binding. So on the left here, we can see how the shape of the active site changes slightly when the substrate binds to it. This formation of the enzyme substrate complex is called the induced fit model. The substrate interacts with the enzyme through non-covalent interactions in the active site, so things like hydrogen bonding or dipole-dipole interactions. Perhaps some of these non-covalent interactions cause a shift in electron density, which make it easier to reach the transition state for the reaction, therefore lowering the activation energy and speeding up the overall reaction. Next, let's say the bond between the two triangles breaks and we get our two products here, so two individual triangles. And the enzyme active site goes back to the original shape and it's ready to catalyze another reaction. Next, let's talk about a homogeneous catalyst, which is a catalyst that's present in the same phase as the reactants in a reaction mixture. So let's look at the hydrolysis of sucrose to turn into glucose and fructose. This reaction can be catalyzed by the hydronium ion, H3O+, and since sucrose, our reactant, is an aqueous solution, and so is the hydronium ion, we can say that the hydronium ion is a homogeneous catalyst, and it's a source of protons to catalyze this hydrolysis reaction. Here's a drawing of the sucrose molecule, which is a disaccharide composed of two monosaccharides. Glucose is over here on the left, and fructose is over here on the right. And these two monosaccharides are joined by an ether linkage. So we can see this connection here. All right, this oxygen in between our two monosaccharides is an ether linkage, and ethers are fairly non-reactive. Since ethers are generally unreactive, the hydrolysis of sucrose is a pretty slow reaction, and to speed it up, we need to add an acid catalyst. So if we add an acid catalyst and we have hydronium ions in aqueous solution, a lone pair of electrons on the oxygen on the ether will take this proton, and these electrons move in to form water. Protonation of the oxygen gives the oxygen a +1 formal charge and allows an acid catalyzed mechanism to proceed. And there are more steps to the mechanism, but ultimately sucrose is broken down to form glucose and fructose in this acid catalyzed hydrolysis of sucrose. Honeybees actually have the enzyme to convert sucrose, which is table sugar, into glucose and fructose. And since fructose is sweeter than sucrose, honey is sweeter than table sugar. A heterogeneous catalyst is a catalyst that's present in a different phase from the reactants in a reaction mixture. As an example, let's look at a hydrogenation reaction. In this reaction, ethene reacts with hydrogen on a surface of platinum to form ethane. Now, since the platinum is in the solid form and our reactants are in the gaseous state, the platinum is an example of a heterogeneous catalyst. So here in our picture, we have our piece of platinum metal, and both the ethene molecule and hydrogen are adsorbed to the surface of the platinum metal. Next, the bond between the two hydrogen atoms breaks, and we get the two individual hydrogen atoms bonded to the surface of the platinum metal. Eventually, these two hydrogens add across the double bond of ethene and form the ethane molecule, C2H6. So the hydrogenation of ethene to form ethane is catalyzed by the presence of the platinum metal.